Hi, this will be a discussion of how to use multiple files in C and C++ and how to call methods and pass data between them. Using multiple files is a core concept that is critical to any large project. Projects will often have hundreds, if not thousands, of files. Developers will often split up code into different files to make maintenance easier and to reduce compile times. In order to understand how multiple files works, it is important to understand how the compiler works. The compile, or build process, takes the source code from an application and turns it into machine code that is executable by some platform or operating system. This process is made up of 3 sub-steps. Each are important to understand. Steps are preprocessor, compile, and link. Each step does an important part of the build process and is required to create a program that will run. The preprocessor is always run first. That's why it's called a preprocessor. Its job is to get the source code ready for compilation. It resolves any included external header files, expands any preprocessor macros, and handles pretty much any other thing that starts with a hash sign. These are called preprocessor directives. This is how external function declarations get put into code. When we use the hash include preprocessor directive, the contents of the included file are actually pasted into the source code file right before compilation. This allows things like functions in the standard library to be declared so that you can use any of the standard functions. The results of the preprocessor is a thing called a compilation unit. It is still a text file and contains C code, but it is now ready for the actual compile process because it doesn't reference anything external. The actual compile step takes each compilation unit and parses the C or C++ text to turn it into machine code. Each compilation unit is processed completely independent of any other unit. The compiler does syntax and error checks during this stage so that it can ensure that all code can be turned into valid machine language. The compiler also ensures that all calls to functions that are outside the compilation unit have valid syntax. The compiler for a specific compilation unit may not know exactly what a function does, but it must know what the function's name, arguments, and return types are. If a function is called that the compilation unit does not know about, the compiler will generate an error saying that the function is undefined or unknown. For functions in the standard library, the declarations of what these functions do are part of the include files that were added by the preprocessor. This is what tells the compiler what functions like printf and cosignf look like so that it can know how to compile calls to them. The result of the compilation step is an object file that contains all the code for a specific source file and a list of external functions that need to be called. The compiler still doesn't know what the external functions do, but it does know that they do need to be called and how they are called. The last step is where everything is put together, and this is known as linking. All of the object files from all the different compilation units are taken and put together into a final executable. The linker takes the list of external function calls from each object file and finds out where the code for them actually is defined. If the code for an external function was defined in another compilation unit, the linker makes all the calls to that function point to that compilation unit so that it can be run. If the function is defined in a library file, the linker routes all calls to that library file because that's where the code lives. When complete, all function calls will have been linked to the correct code locations so that the program can run. There are several problems that can happen in this stage regarding the hooking up of the function calls. First, the actual code definition for a function may not be found. If the linker cannot find where the actual code is in any library or compilation unit, it can't find the correct place to route the function call. The compiler may have been given a declaration that defined the name of the function and what its arguments look like, but the linker may not be able to find the actual code if it wasn't included somewhere. This can make your program not work, so the linker generates an error. It'll generate an error that will talk about an undefined reference to something. This means that the compiler did know about the thing, but the linker can't find it. So it's not a compile error, it's a linker error. Second, the linker may find multiple things that have the same name, arguments, and return values in different object files. Because the compile process works on each source file independently, there is no checks to ensure that two different compilation units don't define the exact same thing. If this happens, the linker can't figure out which one to use. It's not its job to decide which code to use and which code to throw away. So it will generate an error called multiple references. Either of these errors will cause a problem and cause the linker to fail, and your program will not be generated. So as we can see, each of these steps is an important part of the build process, and they all contribute to the ability to use multiple files in a project. You will notice that I used two different similar sounding terms in my previous descriptions: declaration and definition. The differences between these two terms are very important. A declaration is a piece of code that defines what something is, but does not say what it does. It describes the name of something, any input it has, output it has, or fields it may have. It does not define where the actual code for that thing will be, just what it looks like. You can think of it like a name tag for a function, structure, data, or class. It can be used to identify a thing, but it is not the thing itself. The definition is the actual thing itself. It does define where the code for that thing will be, what compilation unit it will be in, and it actually has all the code that implements whatever that function, structure, class, or data does. This is all very important because, as we talked about before, things can only be defined once in one compilation unit, or the linker will become confused when there are multiples of the same thing. To handle this, we use two different kinds of files: source and header files. Source files are what become the actual compilation units. They usually end in C or CPP extensions. They contain the actual code we want to be compiled. Everything that gets compiled into the runtime code is put into one and only one source file. This way, when the linker runs, we can be sure that there is only ever one example of each thing that it has to link to. Header files usually end in .h or HPP, and they contain declarations for things. They have the info that describes what a thing is, but do not contain the actual thing themselves. We include header files into our source files using the #include preprocessor directive when we know that something in the source file needs to call or reference something that is declared in a header file. Again, the header file just has a description of the thing, not the actual thing. So it's just the information the compiler needs to validate a call to something. It does not tell the compiler what it actually does. With this system, we can then have multiple source files with different things that can access items from other source files via the header files. Since header files do not contain the actual code for things and just declarations, it is perfectly valid to include the same header file into multiple source files. The actual code for a thing will still only be defined in one source file, so it will link properly. Let's take a look at an example. Here we have a main function that is going to set up drawing with Raylib, a game development framework. At the top, we're including our header file for Raylib, raylib.h. This includes all the declarations for all the functions in Raylib. This will allow our file to compile because the compiler will know what these functions are from the header file, and the linker will find all the code in the Raylib library that we've included in the project. Now let's say we want to move our drawing code into a function because we think it'll get large later. So we can create a doDrawing function. We can put our code in the function. We can call our function instead of our code. We can build, and everything's fine. We've got our circle. This works because our function is declared before it's used. It's in the same compilation unit. So when the compiler comes through, it will find this function, find the code, and call the correct function. Now let's say we want to move our function to its own file, because as we know it's going to get really big later. So we add a new file to our build system. In this case, we're going to add another C file. We're going to call it drawing.c. We're going to add it to our example folder. We've got a new file. Cut our function, put it in here. Our function does use raylib, so we're going to need to include raylib. And now we've got our two files. Toggle next to each other. So now we've got our two files. If we try to compile this, we're going to get an error. DoDrawing is undefined. This is because in our main file, there's no longer a declaration of our DoDrawing function. So this compilation unit doesn't know about the function defined here. What we have to do is add an additional header file that can tell main what the function in drawing is. So we're going to add a new header file this time. I'm going to call it drawing.h. In this header file, we're just going to define our function, or actually, sorry, we're going to declare our function. We're just going to say it doesn't return anything, it doesn't take anything, and it's called DoDrawing. And we're going to go back to main, and now we're going to include drawing.h. Now if we build, everything is fine, because when the preprocessor comes and runs through, it includes drawing.h, which includes just the declaration for our DoDrawing function. DoDrawing can be called. The linker points it to this version of DoDrawing that we have here in this other file. So now if we run it, we once again still get our ball. It is very important when you're using multiple source files that you tell your build system to build all the files that have code that is needed. In Visual Studio, this is done by adding all the source files to the project. Here we have both our main and our drawing C files. With makefiles and CMake, this is done by ensuring that all the files that are needed for your project are included in the list of source files. When using GCC or MinGW manually, you must specify all of the source files to the command line in order for the compiler and linker to know to use them. Just including a header file does not automatically cause the corresponding source file to be included in the build process. You could have include files that have no corresponding source file. If you miss a source file, then you will get an undefined reference error when you link. Okay, let's try something slightly more complicated. Let's say that we don't just want to call DoDrawing, we want to pass some data to our function about what kind of ball we want to draw, where it is, how big it is, and what color it is. And we want to use a structure for this. So we can go into our header file, we can define a structure. We can give it a position. We can give it a size. And we can give it a color. Now, some of these things are from raylib, so we have to include a raylib in our header file, and that's perfectly fine. And then we can make our function take our ball info. So now our DoDrawing function takes a ball that we can draw. So we can go back here to our draw function, and instead of hard coding this, we need to take in our ball function, our ball. But this gives us an error in Visual Studio. Why? Because this file doesn't actually know what a ball info is. So to do that, we need to include our drawing header file in our drawing C file. We know that our drawing header file includes raylib, so we don't actually need raylib twice in here. we can change this to drawing.h. Now our function knows what a ball info is because it got it from including the header file. So now we can say ball.position.x, ball.position.y, ball.size, and ball.color. Now our function here is going to read all of its parameters from something that's passed in. Our drawing function here knows that it now actually takes a ball info, so we need to define a ball here. Because our ball info structure is defined in our drawing header file, we can use it in our main as well. So we'll say ball.pos.x equals 100, pos.y equals 200, ball.size equals, make the ball a little smaller, color equals, make a green ball this time. And we can pass our ball into our function. We got no problems. We say build. We have just warnings because Wikilib doesn't like warnings. And we can run it, and now we have a green ball. So what we've done here is we've defined a data structure, or declared a data structure in our header file, declared a function that takes that structure, made our function use that structure as input, and defined a variable using that data structure in a different file. So we're passing a structure from one file to another. So as you can see here, we're passing data through a function. Now let's say we actually wanted to create a single ball as a global variable and share it across multiple files. So the simplest thing we can think of is, let's say we just put our ball in our header file and get rid of our ball here. So we'll define the ball in the header file. We will set up the ball in our main file, and let's say we just want to use the one global ball. We'll get rid of our ball here. We've still got our global ball, so now we're just using our global ball, which is included in the header. Here's where we declare our ball and where we define our ball. We set up our ball and we use it here, which we don't need to call anymore. So now if we actually build this, we'll get an error. Because this ball is being defined in a header file, each compilation unit, both main and drawing, are going to attempt to create a global called ball. The linker will say you've got two things that are named the same. That can't happen, and you'll get a conflict. So what we have to actually do is use the extern keyword to tell us that this is not a definition of a global ball, but a declaration of a global ball. If we do this, we're no longer defining a ball in either file, and we won't get multiple definitions at the end. The problem is we don't have any definitions now, and we'll get an undefined reference because there's no actual balls anymore. So what we need to do to resolve that is to define a single ball inside a single CPP file, or C file, which we'll do here in our drawing file. So we define a single ball in our drawing file. We're still going to set it up inside our main function, but because it was defined as extern, the linker now knows to hook it up at the end. And if we run, we still get the same results. We're no longer passing our ball across, but we're using a shared global. So this is another way that you can pass or share data between files using something like a global, but you do have to use the extern in the header where you define it. The last thing to cover with headers is the problem of multiple declarations. Just like the linker has a problem with multiple definitions of a thing, the compiler can have a problem with multiple declarations of a thing. As your project grows and you get headers that may include other headers and may include other headers, it can be difficult to ensure that each header is included in one compilation unit only once. To help with this, modern compilers provide a feature called #paragma_once. As you can see, Visual Studio puts it in by default anytime you define a header. This tells the preprocessor, if you see this file more than once during the same compilation unit, only include it once. Only grab the first one. This ensures that the preprocessor only includes everything once, and everything will compile correctly because you won't get multiple declarations. The paragma_once has nothing to do with linking or source file compiling. It simply is used by the preprocessor to help ensure that we only declare things once in one file when needed. You may also see older code that uses a #ifndef test. It kind of does the same thing. These are often called include guards, and they use a slightly different preprocessor feature to do the same thing. They're an older way of doing this sort of guard. They're from before paragma_once was used by modern compilers. The use of it is now widespread, so there's no problem using it at all. But yeah, that's about it. Hopefully this overview will help people understand how to use multiple files in projects, because it's a very important thing during game development. Thank you.